discussing Module 10 and Module 11. Medyo crack na yung aking voice. Almost 48 hours na ako na gising. So, hopefully, matapos natin na meron pa akong boses. So, just let me know, class, kung nakakat na or choppy ako. I do believe parang 30 minutes ago, wala pa rin kaming internet connection. So, wait. So ngayon lang kami nagkaroon ng stable na internet connection. So just let me know. Okay, so let's start with Module 10. So we'll be discussing physical significance of the orbital quantum numbers. And so far, ang na-discuss na natin is like last module natin we discussed. Kita nyo naman yung screen? I mean yung slides. We have discussed the solution for the R equation, for the phi equation, and for the theta equation. And we found out that we have three quantum numbers. We have the principal quantum number n, which was given to us by the R equation. We have the phi, we have the m sub l, okay, which was given to us by the phi equation, and we have the l orbit. We have the quantum number l, which was given to us by the theta equation. And yung kanilang relationship to one, I mean, yung limits, the R equation also gives us the limits for the L, right? So, the theta equation gives us the limit for the M sub L. So, lahat sila ay limited, ano? And of course, we know that the principal quantum number is a limited number. So may constraint siya. So meaning quantized silang lahat. So yun yung reason kung bakit they are the quantum numbers, kasi meron silang mga physical constraints, mathematical constraints. That is the reason why quantized lahat ng mako-calculate natin coming from them. So yeah, for this module, what we will be doing is we will just be checking the physical significance of these quantum numbers. So number one, we'll be discussing the principal quantum number, what is being entailed by the by the principal quantum number. And of course, we have the angular dependence of the wave function, the quantum numbers L and M sub L. After we have discussed the possible solutions for R, for theta, and for phi equations last module, we also tried to calculate for the complete wave function, right? And yeah, as much as I can remember, you did great, since I gave you at least two, right? Yeah, two sample problems for the calculation of the complete wave function. So what we'll be doing now is we'll be checking the angular dependence. We won't be able to like give the entire math for this one, since this isn't para kind of part of the scope of physical chem 3. But then again, if you have time, everything's a good read. So I do recommend that you like try to look at the advanced topics regarding that. But then again, since hindi siya scope ng physical chem 3, so we're trying to like trim things down. So para hindi na din like mahirap malawak yung ating coverage for the finals. Okay, so yeah, I will be discussing the principal quantum number, whatever is being entailed by that, and then the angular dependence of the complete wave function. Okay, so maybe a short intro first. So the mathematical solutions of the Schrodinger equation for hydrogen-like atoms has thus revealed that there are three orbital quantum numbers. We have N, L, and M sub L, and their magnitudes are related to one another by equations 9.24, 9.27, and 9.25. Yung 9.24 natin, class, yun yung solution natin for the ano yung first natin for the P equation. It's 9.24. Yeah, tama, di ba? And then we have 9.20 no, yung 9.24 natin is for the for the P equation. Yung ating 9.25 comes from the um, theta equation, and yung 9.27 natin comes from the R equation. It's just that kaya natin skip lang yung 9.26. I mean, yung relevant na equations for this one is relation kasi yung tinitingnan natin. So sa 9.24, if meron kayong screenshot ng previous slides natin, hindi ko na sinama, you would see na related si M sub L natin at KL. M sub L values are being limited by the L values. And sa 9.25 natin, yung M sub L naman natin ay limited, ay yung L natin is limited by N. No, 9.27. Ang gulo ko. So yung M sub L values natin is for 9.24, and then we have the L values for 9.25, and for 9.27 we have the N values, ayan, and the limitations for the L values. Okay, I'm sorry. And then special notations been introduced to designate the quantum numbers N and L and the orbitals to which they correspond. This is something that you have already encountered and that you are familiar of. Coming from general chemistry or the principles of chemistry, right? So we have the principal quantum number n, which is given first, and then followed by a letter that indicates the quantum number L. Okay, so as follows, we have when you have L is equal to 0, that is the lowest number for L, right? So we have n minus 1, which is the limit for L, so from 0 to n minus 1. So for n is equal to 1, so we only have one L value, which is L is equal to 0, and that is the s orbital. Okay, so that letter indicates, I mean, letter S indicates that L is equal to 0. That is your s orbital. And then for L is equal to 1, yung designation natin is letter P. So that is your p orbital, obviously. And then for L is equal to 2, we have the d letter or the d orbital. And for L is equal to 3, we have F. From then on, we follow the letters in alphabetical order. So L is equal to 4, G yun. L is equal to 5, H yun. But for now, as far as we had advanced the periodic table, the elements hanggang F orbital pa lang tayo, right? So, and of course, as time goes by, as we advance our technology, we would hopefully see na may mga sumunod pang mga orbitals na makukuha. But anyways, the letters S, P, D, and F relate to the description sharp, principal, diffuse, and fundamental that the early spectroscopists had given to series of lines in atomic spectra, pero hindi na sila applicable ngayon. But we retained the letters. We have S, P, D, and F. So as an example of the use of this notation, we have a 3p orbital. Okay, when we say 3p, ibig sabihin nun, we have n is equal to 3, and then we have L is equal to 1. Kasi P is the letter indicating that L is equal to 1. So for a 3p orbital, we have n is equal to 3 and L is equal to 1. So when you say, for example, we have a 4f orbital, so yung n natin is equal to 4, and yung ating L is equal to 3. So ganun lang siya lagi. And I know na, alam nyo naman. Okay, so let's talk about the principal quantum number first. The principal quantum number n. So inspection of previous relevant equation shows that the principal quantum number n, that the only one that contains the energy is the R equation. Kung babalikan natin, yung ating phi equation class is just your phi, right? Wave function, and then yung ating phi na coordinate, right? And then sa theta natin, we have the M sub L, and then yung theta wave function, and then yung theta natin na coordinate. But for the R equation, nandyan yung ating R coordinate, and of course, the R wave function plus yung ating energy kasi sa kanya yung natira. Okay, so yung ating energy term, right? So, which is equal siya lahat sa ln L plus 1, L times L plus 1. So it therefore allows that the energies for a hydrogen atom depend only on the solutions of the R equation, of the radial equation, and not at all on the solutions of the theta and of the phi and the theta equations. In other words, the energy depends only on the principal quantum number n, which comes from the R equation, and not on L and M sub L. And this is only true for hydrogen-like atoms. Again, class, for our previous discussion, we are just trying to describe quantum mechanically how a hydrogen-like atom would behave or kung ano yung itsura ng kanyang magiging orbital and ano yung magiging possible wave function niya. Sa hydrogen-like lang. The reason being, once na magkaroon na tayo ng additional na electrons, I'm sure you know it by now, that electrons actually affect one another. The reason kung bakit applicable lahat ng discussions natin just for the hydrogen-like atoms is because for a hydrogen-like atom, we only have one electron, and that electron revolves around a solid body, which is the nucleus. So regardless kung gaano kadaming protons and neutrons meron doon, you have a single body. Okay, so yun yung nucleus natin. And then you have another single orbiting body, so around the nucleus, which is your electron. So ibig sabihin, one electron system lang siya. The reason why this isn't applicable to higher order atoms, when I say higher order atoms, we're talking about those which has two electrons or more. Those electrons actually do not behave once na may kasama na silang electrons. They do not behave the same way as they did during the time na hydrogen-like lang sila. Got it? All because they are trying to also repel one another kasi nga electrons sila, they have the same charge. Also, they are trying to shield one another, right? So meron silang shielding effect. If you're going to like look at the Slater's rule or i-check natin yung calculation natin for ZEF, you would know na sobrang laki at significant talaga yung I'm sorry. Sorry, kalapit kami ng kalsada. So, maraming nagtitinda. Yeah, as I was saying, so we know for a fact that electrons do affect one another, and they are like greatly affecting one another, you know? And yeah, so one of the consequences for this is the huge difference in their ionic radius, right? For example, you got isoelectronic atoms. Like for example, you have fluorine negative, a fluoride negative. We have, for example, neon. We have fluoride, and then we have neon, and then sodium atom, sodium ion. Ayan, so any positive. So you have three different atoms which are all isoelectronic, right? So with one another, pare-pares lang sila ng number ng electrons, but you would see their physical appearance vary greatly from one another. Sobrang laki ng fluoride atom compare natin sa napakaliit na sodium ion, all because of the ZEF or the efficient nuclear charge. So meaning napakalaki ng role or na it is of great significance, ano, yung effect ng neighboring electrons. So again, class, yung i-discuss natin ngayon is not something na completely different topic from what we had discussed before, like last time. Nag-branch out lang siya. No? So again, applicable lang to for hydrogen-like atoms. Okay? So dami kong kwento for that. We can obtain the energies by substituting the various solutions for R listed in table 11.4. As I have mentioned, hopefully may screenshot kayo ng last nating slides or at least yung ating tables into the R equation and solving for E. When this is done, the permitted energies are given by this expression. So we have E sub n, regardless of what n is equal to negative z squared, E squared over 8 pi epsilon Bohr radius n squared. Okay, so again, class, yung epsilon natin is just the electric permittivity in a vacuum. Okay, so constant naman. So the lowest or the most negative energy occurs when n is equal to 1, and this is therefore the most stable state or the ground state of the atom. So since when n is equal to 1, L must be 0, this is the 1s state. Okay, so ang lowest natin, class, most stable na state ng isang electron, hydrogen-like electron, is the 1s state. Okay? So the R equation and therefore the value of n determines the expectation value of the distance between the nucleus and the electron. Thus, If n is equal to 1, the electron is more likely to be close to the nucleus than if n is equal to 2, and so on. This may be represented quantitatively by diagrams in which the function r is plotted against the distance r. So the reason, class, why everything would that you would see here is nakagraph is because we are trying to like make sense, like physical sense, and we're trying to make sense of what we have already discussed regarding the orbital quantum numbers. So we're just trying to make sense ano yung kanilang physical meaning, ano, and the one of the ways that we could see that clearly is by looking at the graphs. So we are trying to plot things from here. So for this one, you can plot, class, yung ating r, yung ating wave function by the distance r. So if we're going to look back, asan ang ating r equation? Yeah, wait. Where did I put that? I see, hindi ko siya isinama. Okay, so for example, if you're going to look back at the table 11.4, sige na nga, tumingin na nga lang tayong 11.4. So, stop ko na yung sharing. Para lang malinaw sa atin, class. Para kita ninyo, like, bakit magsi-zero siya. Yeah. So, habang tumataas yung value ng R natin. Okay. So, ating table 11.4. Okay, got it. Can you still hear me?
Yes po.
Okay. I hope you still enjoy the class. And sana hindi kayo antukin as much as I am. Ngayon. So, as you can see, we have table 11.4 here. These are the solutions of the R equation. Hindi to particular class just for hydrogen. This is true for hydrogen-like atoms since hindi naman nila ginuwan yung ating Z. I don't know if you can see this, but I would try to zoom in. Ayan, mas kita nyo ba siya? No. I think todo na to. Mas kita naman. Okay, so this is your R equation, right? So just for example, just for the 1s orbital. So for the 1s orbital, we have this wave function. You can still hear yung Vendi. So we have yung vendor. So we have, for example, for R10 or the 1s orbital, we have R is equal to 2, right? So multiply to Z over the Bohr radius raised to 3 halves times E raised to negative ZR over the Bohr radius. As you can see, class, we are trying to plot here. Of course, ang pwede lang natin plot is the R na wave function, yung value ng R, and yung value nitong R natin na coordinate. Okay? Kung ano yung radius. Okay? So, of course, regardless, class, kung ano yung atom, yung hydrogen-like atom ninyo, so put in nyo lang yung kung ano yung kanyang Z, yung kanyang atomic number. Okay, so as you can see, class, you try to look at it this way. So this is just like y is equal to something x. Okay, so just to relate y and x. Okay, it's just that yung y natin is yung r na wave function and yung x natin is yung r natin na coordinate. Okay? So yung R natin, class, as you can see, this is part of the exponent of the natural number E. So E raised to negative ZR. Okay? So negative ZR. So as you can see, class, yung R natin dito, habang lumalaki yung ating what do you call this, yung ating value for R, you would know na lalaki yung value ng ZR over the Bohr radius, ano? Since constant yung Z, constant yung Bohr radius natin, habang lumalaki yung R, you would see na mas pa-negative ng pa-negative, right? Pa-negative ng pa-negative yung exponent ng E. So, and as we know, class, the more na negative siya, I mean, sobrang liit niya, the more na magiging zero siya. Right? So, like, palit yung value natin. So, pwede na natin siya i-consider na zero. You know? So, kumbaga habang lumalaki yung R natin, eventually you would know na maging zero siya. Like for example, pwede naman yung itry lang siya sa calculus, like just have to use arbitrary numbers. Like for example, we can use like e raised to negative, let's say 100. So that would still give you a number, right? So that would give you 3.72 times 10 to the negative 44, right? Times 10 to the negative 44. What about 200 maybe? So what about 200? So that would still give you 1.38 times 10 to the negative 87 na siya. So as you can see, sobrang liit niya na. That's 0.00000, right? So 86 na zeros. Ano, 86 na zeros. No, before hitting number 1. So, sobrang liit niya na halos makonsider mo na siya na zero. And try class na, for example, e raised to negative 1,000. So, negative 1,000, for example. That would give you zero. Right? So, ibig sabihin, habang lumalaki yung R value natin, you would come up with zero value for this one. So, yeah, for the R, right? I mean, yung answer natin for the R. Okay, so as you can see, class, lahat ng solutions natin ng R equation have that term. So we have e raised to negative zr over a naught or the Bohr radius. Okay? So for 10, for 20, for 21, lahat yan sila class, merong e raised to negative zr over a o. So yun yung reason kung bakit generally you would see na everything would be, I mean, zero at a high R value. Okay? So when I say R class, I'm talking about the possible values for the coordinate. Ha? Kapag lower case na R, kapag uppercase na R, I would say R wave function. Okay, so much for this one. Um, yeah. Okay, so yeah, that's it. So for the um yeah, for the R versus R, I know R versus R. I mean, along the x-axis, you'll be plotting the R values, natin, the coordinate, and then the R equation values or the R wave function values sa y-axis natin. So you would have these graphs class. So note that because of the exponential factor, as we have seen, so exponential factor yung ating R, no? Appearing in the expression for R, the function approaches zero as R becomes large. Sorry. Okay, so yeah, as you can see class, nag-zero siya, nagda-drop siya to zero. So for example, for the 1s orbital, I have here the graph, this one, the one in the middle. So this is n is equal to 1 and then L is equal to 0. Can you see it clearly? Or this is the 1s orbital. You can see class na habang tumataas yung ating R value, the coordinate, okay, value, nag-drop siya into 0. Okay? So yung ating, yeah, so nag-drop siya into 0 for those na malaki yung R. So, what does that mean is habang lumalaki class yung radius, no, yung radius ng ating atom, nagda-drop into 0 yung ating curve. So, makikita niyo pa naman yung ibang mga curves natin. For L equal to n minus 1, this approach to 0 is monotonic. Okay, so with no maxima and minima. So, this one. Yan. So, for no, this should be for L equal to, yeah, yeah, sorry, with no maximum and minima. But for other values of L, the function passes through 0 at various distances. And there, are maxima and minima. The number of radial nodes where r is equal to 0 is equal to n minus L minus 1. As you can see, class, for the 1s orbital, wala tayong nodes. As you can see, isang set lang siya ng line. And nag-approach siya sa 0 habang tumatas yung r. Okay? But for the 2s orbital, okay, so meron tayong 2s orbital, so n is equal to 2 and L is equal to 0. You can see, class, na dumaan siya sa 0. Okay? So as in, nagkaroon talaga siya ng 0. Okay? And then nagkaroon siya ng minima. For L is equal to 1, of course, we know for a fact that when you have N is equal to 2, you can have two different L values. So we have L is equal to 0 and L is equal to 1. For L is equal to 0, you have a minima right here. And for L is equal to 1, you have a maxima right here. And then bago siya mag-drop into 0. And then for N is equal to 3, we have three different L values. So L is equal to 0, 1, and 2. For N is equal to 3, L is equal to 0, that's your 3s orbital. You can see, nagkaroon siya dito ng node. When we say node, class, nag-0 talaga yung value. Okay? So nagkaroon siya ng 0 value um, at this point. And then nagkaroon ulit siya ng another na 0 value at this point, right? Tapos bago, so this is yung minima natin, and this is your maxima, and then bago siya nag-proceed to like yung limit natin na mag-approach siya into 0. And then we have L is equal to 1. So ganun lang din. So we have 1 and then 2. And then for L is equal to 2, we have, for this one, it looks like 1 lang siya. But yeah, for this one, class, basta ang calculation natin, class, is every number of n natin, just have to deduct yung L value natin and then minus 1. So for this one, wala siyang node. So since n is n minus 2, minus 1 is just 0, right? So for this one, meron siyang isang node, and for this one, meron siyang dalawang node. Okay? So when we say node, class, as we have already discussed sa previous, nung midterms natin, when we say node, walang chance, class, na magkaroon tayo ng may existence ng electron or ng particle doon. Wait lang. Yeah, sorry. Uh, Business. Okay, so yeah, so we have the number of, again, radial nodes, as I was saying, where r is equal to 0 is equal to n minus L minus 1. So again, class, when we say node, yung r natin is equal to 0. Since yung r natin is your wave function, and we know for a fact na kasama to sa midterms nyo, right? Yung ating wave, kapag 0 ang wave function natin, ibig sabihin nun, class, wala tayong particle. So you just can't find any particle sa isang space. Right? Kasi nga, yung wave function natin is equal to 0. Kung yung wave function mo, class, is equal to something, so may something. So multiply mo na lang yon by itself, or get the, if real siya na wave function, or kung complex naman na siya na wave function, you just have to multiply this by the complex conjugate, no? And you would know the probability kung ano yung chance mo to finding that electron or that particle in a specific region. But then, class, if your wave function is 0, automatically wala kang electron, okay, or wala kang particle. So for the 1s orbital, wala tayong node. For the 2s orbital, meron tayong isang node. For the 2p orbital, wala. For the 3s orbital, we have 2. For the 3p orbital, we have 1. And then for the 3d orbital, we have none. Okay. So we have seen that the probability that an electron is in a volume element, d tau, dx dy dz, is given by psi square, right? d tau. So regardless kung anong wave function natin, this is a general rule formula for finding the probability. Or we have psi squared d tau, right? If the wave function is real. Sorry. If the wave function is real. For we know class for a fact that wave functions are real, have complex conjugates just the same as the wave function. So yeah, so yung psi square natin would just be equal to psi square. Ay psi star natin would be just equal to psi square. Right? So kasi nga real naman siya. So if we divide by d tau, the result psi square, so we have psi square d tau. Kapag dinivide natin siya by d tau, hindi na probability lang yung nakukuha natin, but we are getting the probability per unit volume, okay? Or the probability density. So for an electron in the 1s state, the probability density obtained from the first item in table 11.5 is therefore we have a psi 1s square. So, kaya siya class psi 1s square is, again, real naman siya. Again, as I have mentioned sa inyo before, especially for the phi equation, right? Sa phi equation natin, meron tayong complex solution and we have the real solution. So, of course, we are looking forward na real yung ating gagamitin kasi real naman yung ating mga values na hinihingi. Ano? So we have the psi 1 s square na lang. Okay, so assuming na real value, real naman sila, yung wave function natin. So that is equal to e raised to negative 2r over the Bohr radius divided by pi multiplied to the Bohr radius cube. Okay, so a plot of this function against r is shown in this figure, and we see that the probability density has a maximum value at r is equal to 0 and falls towards 0 as r increases. Okay, so yeah, as you can see class, yung ating r value for this one, kapag tumaas yung ating, of course class, yung radius natin could never be negative. Like, radius natin is, I don't know how you would get a negative length, right? So parang may utang ka pa, parang ganun. No? So we could only have 0 and then, of course, up to infinity, like kung gaano ka laki yung sphere. So for example, for 1s, so yung ating if you would try to calculate for the wave function by putting r is equal to 0, you would see na yun yung kanyang magiging maxima. Okay, so yun yung no, not the maxima kasi hindi naman siya like curve na may maxima and minima. The maximum value for r, okay, would be at r is equal to 0. The maximum value for the r equation, for the r wave function, is when r is lowercase r, or the coordinate r value is equal to 0. Nakakalito, no? Since pares lang silang r and r, phi and theta and theta. Anyways, so I hope nasusundan nyo. If not, class, kindly caught me and then try to ask anything. And then it falls towards 0 as r increases. Tulad na na-discuss natin kanina, since yung r natin class is part of a negative exponent. So you would see na habang tumataas yung kanyang value, lumiliit ng lumiliit yung value ng ating wave function. Okay? So hanggang sa maging 0 siya. Okay. So it is of greater interest, however, to consider the probability that the electron is present at a distance between r and r plus dr. Right? It makes so much sense, class, right? Since we are not looking forward to like sticking to the value of the Bohr radius, for we know that the Bohr radius is like giving us the radius of an electron in a hydrogen atom, not in a hydrogen-like atom. Okay, so since we know class for a fact na yung potential energy na meron yung ating electron is being governed by the Coulombic force between the nucleus, which is a positively charged, and yung ating electron. So yung kanilang attraction, right? So, and we know class na for hydrogen-like atoms of higher order, of course, isa lang yung electron natin. Pero, may nagvi-video kaya yata. Sorry for that. Where was I? So yeah, again, yung borages natin is only good for hydrogen. For hydrogen-like atoms, however, we know na medyo nagva-vary yung ating borages and we just have to like calculate for the multiplier para magamit pa din natin yung borages as a constant. But we know na since Coulombic force nga yung and attraction between unlike charges, alam natin na habang tumataas yung Z, tumataas yung positivity ng nucleus natin, mas nahihila niya yung electron. Right? So, hindi na totoo yung borages. So, the best thing, class, to put it is magbigay tayo ng chance sa electron natin na hindi lang siya mag-orbit sa thin line, like sa isang value lang ng R, na pwede siyang between different R values. Like for example, R plus DR. Like regardless kung ano yung DR. Okay, so actually that is the reason. Thank you. So nagkaroon ako ng burger. So that is the reason why we are like trying to check yung derivative ng lahat ng maths natin kasi we are trying to generalize things. Sorry for that. Can you still hear me? So yeah, the best thing, class, to put it is we allow the electrons to orbit. Um, to orbit at allowed R values and not just stick on the value for the borages. Okay, yeah. So in other words, the probability that the electron is present between two concentric spherical surfaces. So kung meron ka, class, I don't know how to put it. Um, um, for example, uh, ano ba yung ano natin? Yeah, may kukunin ako. Wait. Yeah, this is the closest that I could get. I don't know if this would work, but I do hope so. So, for example, this is the orbit of, for example, nandito sa gitna yung ating nucleus, no? And then, let's suppose spherical yung ating orbit. But what I'm saying is hindi lahat spherical, ha. Like for example, you have the p orbital, the d orbital, they have the f orbital, which is kind of complicated, no? So for the one is orbital para mabilis lang natin siyang maisip. So for example, nandito yung nucleus natin, nasa gitna talaga siya. And ito lang talaga yung kailangan natin, ano, itong outer layer lang. As you can see, class, makapal siya, right? So makapal siya, right? Yung electron natin could be at the innermost surface. So, pwedeng nandito siya, right, located, or pwedeng nandito siya sa tuktok located. Right? And sa atin, almost insignificant to kasi nga, malalaki tayong body. But for the electrons and for the quantum world, sobrang significant nun kasi like you can have two different R values. So yeah, two different R values which are located way distant from one another, you know. So yeah, but then again, pwede din siyang nandito sa gitna itong dalawa. I don't know if you can appreciate yung kanyang thickness. uh Wala din akong board para mag-draw. Yeah. Wait, class. Meron ako naisip. So, what if, ito na lang yung ating share. Anong module natin, class, yung, no, this isn't the laptop that I used for that. Um, you remember, class, yung ating block body? Di ba yung block body natin may cavity siya? And then yung cavity niya is, hindi lang siya basta butas, no? Meron siyang, may kapal. Yun ba yung tamang term sa Tagalog? May kapal. Yeah, may width siya. So, meaning, iba yung girth ng orbit, iba yung radius ng orbit um, dun sa innermost part of it, and then iba yung kanyang radius sa outermost part of it. and I'm sorry, I wasn't able to like get a good um figure for this one. Yeah, but I really hope na naiintindihan niyo siya. So, yeah. So, yan. Um, so, yeah. Where was I? So, meron siyang kapal, no? Yung kapal na yun, class, is yun yung allowed natin na R values para sa kanya. And hindi natin gustong i-constrain lang siya na stick lang sa isang R, sa isang radius lang. So, just for just to generalize things, lagay na lang natin na yung kanyang value could be between R and R plus dr. Okay? So R class is yung innermost, okay? Na innermost na part kung saan siya pwede malocate, and yung outermost yung R plus dr. Okay, and any R value in between that. Okay? So allowed lahat yun. So the volume between two such concentric surfaces is then 4 pi r squared dr. Right? So if you're going to like check yung volume natin, so same lang siya, class. Of course, kung sphere siya, edi 4 pi r cube yun. Right? But then we know na hindi naman completely like anywhere from the nucleus hanggang dun sa outermost part yung ating location for the electron, right? Or else magkakaroon ka ng nuclear reaction. What we are trying to do is we are just giving space, enough space, yung ating electron para ma-allow siya kung anong radius yung kanyang gusto. But then, may specific lang na distance. So, times dr na lang. So, imbis na 4 pi r cube, gawin natin 4 pi r square times the width, which is dr. Okay? And the probability that the 1s electron lies within the distances, wala na pala tayong time, r and rdr is thus 4 pi r square psi 1s square times dr. Okay? So the corresponding probability density, which is now per unit radial distance r, is obtained by dividing by dr, okay, and is therefore 4 pi r square 4 pi r square psi square. Okay, so this function is known as the radial distribution function. Okay. Okay, so a plot of the radial distribution function, so sobrang importante kasi nito, class, kaya natin siya kinuha, no? Against R is shown in the figure on the right. So the curve passes through a maximum when R is equal to the Bohr radius, which is 52.92 picometer. And this distance is therefore the most probable distance between the nucleus and the electron. As you can see, class, yung ating graph, nagpipick siya at the Bohr radius. Meaning, kung hahanapin mo yung electron, most of the time, nandun siya sa radius na kagaya ng Bohr radius. But not necessarily nandun lang siya all the time. Okay? Pwedeng mas mababa doon or mas taas kaysa doon. Okay? So, and this distance is therefore the most probable distance. Most probable lang siya na distance. So, as you can see, class, yung ating probability per unit length, yung 4 pi r square psi square natin, and, versus yung ating distance from nucleus, which is dr in nanometers, you would see na meron tayong curve. Ano? So, ibig sabihin, allowed siya, hindi lang isang value siya, ano? Allowed siya kung saan siya magstay within these regions. Okay, so this emphasizes a very important similarity and also a very important difference, okay, between the Bohr theory and the wave mechanical theory. In the Bohr theory, the electron in the ground or the 1s state, of the hydrogen atom moves in a precise orbit. Ang sabi ni Bohr, ni Niels Bohr, as you can imagine, right, yung ating yung draw how Neil Bohr drawn the I mean how he represented the atoms. So alam mo yun, yung may may nucleus, and then may mga paikot-ikot na ganyan. Um, yeah, na hindi talaga actually. I mean, of course, hindi naman yung totoo. Wait lang, may nakahanap. So, oh, where are we na? So yeah, as you can imagine, yung drawing ni Bohr, na actually ginagamit pa rin ng maraming chemical society. Ginagamit pa rin nila yung ganon, yung may nucleus subs, may paikot-ikot. Alam niyo yun, yung parang ganon-ganon siya, parang asterisk na may paikot. Hindi yun totoo, class, hindi ganon ang itsura ng isang atom. So, I don't know, are they trying to celebrate the significance of the Bohr theory? Or what? Or hindi lang sila ganun ka-knowledgeable regarding the... Yung cast ba natin, yung cast logo natin, may ganun? Or yung atin kayang... actually, hindi ko nakita kung alin yung nanalong logo, no? For the organizations. And also
Meron
for
po, sir.
the... Meron?
Opo.
That was
Ginagamit
unfortunate.
pa rin po.
Oh my goodness. So, sana nila ba, kinontest nyo, dapat sinabi niyo na mali yung representation ng BS Skin doon kasi sino ba nakaisip ng logong yun? Hindi totoo kamo yung itsura na yun ng atom. Anyways, yeah, wag na kayo makipag-away. But it was a funny thing actually to see since akala ng marami ganun lang yung itsura ng atom. Well, no. Well, no. Sabi mo sa kanila mag-chemistry sila just so they would know na hindi. But then as early as general chemistry, I think you already know that the postulate number 4 and number 5 from the Bohr theory actually um, were faulty, right? And they were eventually dumped, right? All because mali yung representation ni Bohr during his time. But then again, class, as I have mentioned, hindi natin masisisi si Bohr during that time kasi wala pang quantum mechanics noon. And he was the first one to advance yung subatomic world. Yan. So hindi pa quantum world noon, subatomic world. So siya yung nag-advance noon and kudos to him, rest in peace. Ayan. So asa na tayo again? Yeah, so in the Bohr theory, naka-dictate lang siya ng isa lang na no, na distance from the nucleus, which is the Bohr radius. Yun lang. While in quantum mechanics, this distance is only the most probable distance. Okay? The electron can be at other distances from the nucleus. Actually, class, if you would read books, ang daming nag-a-admire talaga sa work ni Bohr. Not because all of what he did during that time are like accurate and are still like valid, kasi invalid na nga yung dalawa niyang last two postulates niya. Ina-admire siya all because during the time wala pang quantum mech but he was able to calculate everything hanggang sa postulate number 3 niya accurately. Right? So hanggang ngayon ginagamit natin yung Bohr radius as a constant. So ganun siya kahusay during that time. Yeah, again, kudos to him. So figure below shows plots of the psi squared. For this one, this is for 2s orbital and of a 4 pi r square psi 2s squared for an electron in the 2s state. The latter shows two maxima. Similar plots can be given for 3s, 4s, etc. States and the number of maxima in the 4 pi r square psi square plots is always equal to the principal quantum number. Okay, so as you can see, here, class, this is for the 2s orbital. Okay? So yung probability per unit volume natin, graph versus yung ating distance from nucleus goes like this one. So meron tayong maxima. Okay? So meron tayong maximum value and then another na maximum value. This one is for the this is for this one, class, is for psi square lang. This one is the 4 pi r psi square. Okay, so ito yung ating probability density per volume ay yung probability density natin. Okay, so as you can see, class, meron pa rin tayong what we consider as nodes, meaning nag-drop pa rin siya to 0. Okay, so and then meron tayong maxima. So as you can see, ibig sabihin natin dito, class, is meron tayong two different points kung saan sila more probably magstay yung ating electrons. And then may region tayo na hindi talaga siya magsistay doon. Okay? So for this one, for the 2s state, pwedeng yung ating electron, kung this is just a one electron system, could either be here or here, but definitely not here. Okay? So yun yung physical meaning of this one. So for states where L is not zero, for example, we have the 2p, we have the 3d states, we have to proceed differently because there is now an angular dependence. So for the s orbitals class, spherical lang sila. So wala tayong kailangang i-check na angular dependence. But for the 2p, for the 3d, for L's not equal to zero, meron na tayong makikita na angular dependence. So kung babalikan natin class yung ating yeah, can you still see it? Yung ating table 11.4, as you can see for the 1s orbital. So ito lang, ito yung no, not this one. Nasaan na tayo? The last one, 11.5. Yeah, so for example, for this one class, for the 1s orbital, and so for the 1s orbital, as you can see, wala naman tayong angular dependence. For the 2s orbital, just the same way, R lang siya and yung ating wave function, ano. But when you get to the point na yung L natin is not equal to 0 na, which is, for example, 1. So we have L is equal to 1. You can see meron na tayong cosine theta here. We have cosine phi here, and then sine theta cos phi, and then sine theta sine phi. And then for the 3s orbital, 0 ulit yung L natin. As you can see, wala ulit siyang cosine, wala ulit siyang sine sa ating wave function. Right? So ibig sabihin, iba dapat yung ating treatment for those wave functions na ang L is not equal to 0. All because we know for a fact na may angular dependence na siya. Okay? Nasa na nga tayo ulit? Yeah. Okay, so yeah, we could make plots of the psi square or the wave function with cosine theta and sine theta taken to be unity. Yun kasi maximum nila, right? So yun yung maximum value ng sine theta or ng cosine theta is equal to 1. So for sine theta, mag-equal siya sa 1 kapag naka pi tayo. Tama ba? Let's do it. So yeah. Right. So sine 1 sine pi. Yeah, sine pi over 2. Yeah, so sine pi 90 degrees. Ayan. So 90 degrees ng sine ng equal sa 1. And then for cosine, cosine 180 naman or cosine pi or 2 pi naman would give you 1. Anyways, so ititik lang natin sila sa unity just for us to be able to see yung kanilang maximum values. Such plots would represent probability densities along the axis for which these have their maximum values. So for example, class, if nakadepend siya sa cosine theta, and then yung cosine theta is nilagay mo to maximum, you would see na, for example, dun sa ating ibinigay na wave function, for example, 210, so this is the cosine theta. If you're going to plot this one class, vector siya, magbibigay siya sa atin ng specific na plot, and then magbibigay siya sa atin ng direction. And the direction class for this one is along the z-axis. Yun yung reason kung bakit 2pz yung ating psi function for this one. Okay, so for 210. Anyways, so just for a more practical sense class, since we're just like trying to look at how they would look like in a 3D space, and not necessarily how they would look like, no, but how we could like generalize them. So we have a more usual practice for this one, and that is to make plots of r square against r. Yung recent class kung bakit bumalik tayo sa r square against r at hindi natin ginagamit yung 4 pi 4 pi psi square is because, again, class, may angular dependence siya. So, but then, kung gagamitin natin yung r square lang against r, we can say, class, na we could calculate for the maximum value, but this is regardless of the orientation in 3D space. So, yeah, but still, meron pa rin siyang like significance in a sense, no, for that. But then again, class, again and again, since may angular dependence siya, yung itsura niya in 3D space would actually would not give you a spherical kind of shape in 3D space. They would be oriented different ways. So pwedeng along the x-axis, the y-axis, the z-axis, and they could assume different shapes. Like they could have dumbbell shape for the p orbitals. They could have a clover shape for the orbitals, and donut shape for the um to the z sa z orbital natin, z square natin ng d orbital. And then for f orbital, super complicated na sila. But then you would know, class, na hindi sila spherical lang, right? So however, just to like generalize things, pwede nating i-plot yung r square against r even for those na ang L is not equal to 0. So this is not quite the same thing, since a comparison of tables 11.4 and 11.5 shows us that even when with z is equal to 1, the numerical factors are not the same, right? So in spite of this, however, the plots of r against r, plots of r, the wave function r, against the coordinate r, do give us the general form of the probability density function. So gusto lang kasi natin na ipakita yung probability density function natin, to obtain the function along the axis for which it is a maximum, we would have to multiply by an appropriate factor. So for you to be able to like give the orientation, the real orientation in 3D space, you just have to like calculate for the multiplier, which is kind of dependent on the angle, I mean, with it would definitely have an angular dependence. So plot of r against a plot of the wave function r against the coordinate r for the 2p state of the hydrogen atom is shown in this figure. So as you can see, kamukha lang din siya nung iba, right? As if spherical siya. So yeah, I mean yung distance from the nucleus. For example, class, for example, this is a z, a pz orbital. So makikita ninyo na meron siyang maximum. But you wouldn't know na isa siyang dumbbell shape, right? Because for this one, if you're going just to look at this one, the only shape that would be given to you in 3D space class would be sphere, right? Sphere lang for this one, since binigyan ka lang ng maximum, and then you have different values for the of for r at different values of I mean that would give you different values for the wave function. So class, as you can see here, binigyan ka ng maximum. Okay? So hanggang dun lang yung electron natin. And if you know na, for example, given naman talaga sa'yo na 2pz siya, you would know na yung pinakamalayong yun is somewhere along the z-axis. The maximum distance from the nucleus would be along the z-axis kasi nga pz orbital siya. So somehow, class, helpful pa din to, because this is we're just looking at it in a general way. We're looking at the probability density in a general way. But then again, kailangan pa rin natin ng idea kung ano talaga yung kanyang angular dependence, just for us to be able to like accurately give the give an acceptable, right, an acceptable um, shape in the 3D space. Okay, so yeah, we can also make plots for 4 pi r square, not for 4 pi r square psi square. Okay, against r as shown on the right. So ito naman yung ibibigay sa atin. There are 2 points to note about the significance of such plots. Number one, numerical factor r is not the same as psi. Right? Iba yung wave function natin, class, sa radial function lang natin. Because your wave function is the product of your radial equation, of your phi equation, and of your theta equation. So wala itong angular dependence. And then number two, the plot of 4 pi r square would only represent the probability that the electron is in a spherical element at a distance r from the nucleus if the orbital had spherical symmetry. So we are trying to like make everything spherical here. So if you're going to plot this one. So kayo na yung bahala, class, if you know na nasa z-axis siya, so you would know na ma-orient siya doon. Kung alam mo na nasa x-axis siya or y-axis, you would know it. So, but then kung hindi mo alam, hindi mo siya magagamit to draw kung anong itsura niya talaga in 3D space. Sphere lang talaga yung makukuha mo. In reality, orbitals for which L is other than 0 have maximum values in certain directions. Again, kung z-axis, edi sa z. Kung px, edi sa x. Kung py, orbital, edi sa y-axis. The function 4 pi r square or r square, therefore, does not have any simple significance in such cases kung gusto talaga nating i-drawing siya in 3D space. But plots of 4 pi r square against r are informative as long as one recognizes this limitation. Kung alam mo naman na ang ibibigay lang sa'yo nun ay maximum, tapos bibigyan ka ng sphere, um, na makakatulong siya kung alam mo yung limitation. But if you do not know the limitation class of this one and you just use it wherever you want to use it, you might end up having lots of trouble, than you have before you do the math, do the plotting. Since again, ginagawa niya kasing spherical as if spherical ang lahat. So, yeah, yun lang naman. Ang makukuha lang natin dito na significant talaga na value is yung maximum. And then, try to orient it in 3D space. Ikaw na bahala. First, long as alam mo kung saan talaga sila naka-orient. Okay? So, we have seen that an electron in the 1s orbital. I hope, class, may sense yung sinabi ko. Like, may sense siya. Kasi, ginawa lang natin na general siya. Kasi we'll be discussing a lot of the angular dependence naman sa susunod natin na module, sa module number 11. So, na hopefully matapos natin, cover natin. So again, we have seen that an electron, so for now, cut natin hanggang doon lang muna siya, hanggang sa radial distribution lang. Okay, so just to make things generalized. So we have seen that an electron in the 1s orbital is most likely to be um, at a distance from the nucleus. At a distance, bakit ganito yung sinulat ko? Yeah, so this distance, however, because, okay, got it. So this one, class, is, yeah, wait lang, edit natin. This one, class, should be the Bohr radius, if I'm not mistaken. Yeah. Teka lang, para mamaya pag binigay ko sa inyo, hindi ko na kailangan i-edit kasi makakalimutan ko and I would never find it again. So, magdagdag lang tayo ng equation. Sobrang nakakapagod gumawa, class, ng slides. Pero wala namang magagawa. Tsaka sobrang simple lang ng aking hindi binayaran at kinrap at dinownload illegally na background sa Google. So, yeah. So yung most likely na distance niya is the Bohr radius, right? So from the nucleus. So this distance, however, because of the skewed distribution, as you can see, class, hindi siya pantay. No? Lagi siyang skewed. At nag-favor siya lagi sa isang side. So for example, for this one, so kung 0.592, so along nandito yung ating A sub O, yung ating Bohr radius. And then mas malaki yung chance na nandito siya. Right? So gets natin. So at a distance na greater than the A sub O. So lahat yan, class, makikita nyo sa lahat ng plots natin, skewed silang lahat, hindi sila pantay, hindi sila normal na Gaussian curve, no? So skewed silang lahat. Okay? Yeah, because of the skewed distribution of the orbitals, it is this distance is not the same as the expectation value of the distance between the nucleus and the electron. So, which is the distance the electron is expected to be from the nucleus. We can calculate this expectation value by using the postulate number 6 with the wave functions real and normalized. Kung real and normalized yung wave function natin, class, ito yung makukuha natin na expected value for the radius. Okay? Expected value or the average value. Iba't ibang books, iba-iba yung ginagamit. For sa book ni Leidler, expected value yung term. Pero binanggit niya din yung average value. Okay? So yung expected value natin would be the integral of psi 1s times r times psi 1s, since we know, class, na wave functions ay real for this one. Hindi na natin kailangan kunin yung complex conjugate because that would still give you the same wave function, right? Times d tau, okay, which is, integrating it over all space. So if you got from 0 to infinity, from origin to kahit saan, times 1 of psi 1s times r, psi 1s squared times r times 4 pi r squared Okay, so DR na lang siya. Okay, so for this one, yung decal natin class, if you would see, ginawa na natin siyang DR na lang. So meaning, hanggang saan lang siya allowed. Okay, so yung kanyang not necessarily like titingnan natin siya in of course in 3D space pa din to lahat class ha. But then we are just trying to look kung ano yung kanyang possibility, kung ano yung radius niya, like um like most of the time. Okay, anyways, ito yung aking mga calculus. So introduction of the expression psi 1s in table 11.5 then gives r 1s is equal to 1 over yung psi 1s natin class is the first one that you would see sa table 11.5 natin, ano. So this would give you r 1s is equal to 3 halves multiplying at sa Bohr radius. So yung Bohr radius natin class, this is a constant. Again, ito yung binigay sa atin ni Bohr, but not necessarily sinusunod ng lahat ng atoms natin. Though we have hydrogen-like systems, they do not behave same way as the hydrogen electron. Since yung ating nucleus ay nagbabago, mas maraming protons tayo for this one. So mas marami tayong nagbabago siya. So meron tayong difference ng protons, meron tayong difference sa mga allowed values class na pwede siyang makapunta na orbitals. Like for example, if you would see na meron tayong mga like d orbit, meron tayong mga hydrogen-like atoms, for example, na nasa n is equal to 3, nasa period number 3 na, they could actually borrow the d orbital. So, parang, I mean, madami tayong possibility class possible values for the R. And this is how you calculate it for the how to calculate for the expected R value. So we have three halves Bohr radius. Okay. Yeah, so the reason that this is greater than a sub O is the most probable distance is that the wave functions do not give a symmetrical curve when plotted against R. They are skewed in favor of larger R values for S states with other values of n. The expectation values are given by this one. So we have 3 halves n squared times a sub. Okay. So, meaning, though meron tayong Coulombic force that would actually like squeeze them, okay? So there are a lot more factors that actually pulls them at more distance, okay, from the nucleus. Okay, so which is more more considered, those factors are more considered, and we'll be discussing those factors sa masusunod natin na discussion. So yeah, you have this general equations. We have 3 halves times n squared, regardless kung ano yung n niyo, times a sub O. Okay, so this is your radius. Okay. Yeah. And then last natin na part ng topic na to is anong subtopic for this modules, the angular dependence of the wave function, quantum numbers L and M sub L. Okay? So yeah, again class, yung ating tiningnan kanina is like with respect lang sa N natin, and consider natin lahat, though alam natin na may angular dependence yung L natin not equal to 0. So tinry lang natin siya as if sphere silang lahat, ano. So, but for this one, we'll be checking yung ating angular dependence na. No? So, para lang, general lang natin binigay kanina. Okay, so for this one, we have the theta and the phi wave functions, and they are best considered together. Best considered class together in a sense that you are not just like trying to locate one coordinate. Like, for example, for R kasi class, and kung spherical siya, regardless kung ano yung kanyang R, makukuha mo yung entirety ng kanyang wave function, no? Ng kanyang shape. Kasi pag nakuha mo ng R, bumilog ka na lang. Parang ganyan. So, you got the sphere. So, yeah, you got it already. But if you're going to like look at the angular dependence, hindi mo lang naman siya titingnan sa x and y plane, right? You also would like to know kung ano siya sa x-z plane and sa y-z plane. So for that to happen, you have to consider both and consider together yung ating phi, right? Yung ating phi value, yung ating phi angle, and yung ating theta angle. So yung theta angle natin again sa zx or zy natin na angle, and then yung ating phi is yung ating xy angle. Okay? So, of course, yung equations ng phi and theta, pagsasamahin natin as a function. No? Since both are concerned with the angular dependence of the orbital, so plots of the phi and phi times theta wave function square for values L and M sub L values are shown below. Okay, so it is to be emphasized that these plots are in no way related to distance from the nucleus, but only to the variation of the wave function with the angles theta and phi. This is illustrated explicitly for the PZ orbital, for which the angles theta and phi are shown, and in which the plot is shown in its 3D-dimensional form. If you can see, class, sa S orbital natin, sphere lang siya, wala naman tayong problem dyan. For as long as alam mo yung R, okay niya, madudol mo na. But for example, for the PZ orbital class, you would know, you should know kung ano class yung ating, what do you call this? Yung, ano yung term natin for that one? Yung um, angular dependence. Okay, sorry, I'm lost. Yung angular dependence natin with respect to the z-axis and the xy plane. So for this one class, if you would look at it, we will be needing the two angles. So we would know for this one, for example, class. So for us to be able to know kung hanggang yung maximum na radius with respect to the z-axis, so we have to know the theta. Okay? So, yung maximum natin for the theta, no? And if we're going like to check class kung ano naman what do you call this? Yung ating plot, yung pwede nating i-plot along the XY plane. So, i-check lang natin class kung ano yung magiging dependence yung kanyang theta naman, ay yung kanyang phi naman, okay, phi values. For this one, laging sabay yun, no, yung ating phi at yung ating theta. So, hanggang saan siya along the XY plane and ano yung kanyang distance, largest distance from the z-plane hanggang sa pinakamalit na distance. Kasi, class, syempre, yung ating angle naman, magbibigay siya sa'yo ng iba't ibang distance with respect to the z-plane. Pero isa lang yung kailangan nating value, which is yung angle lang na yun. Which is, for example, for the z axis is the theta lang. Okay? So, yeah. So, ito yung magiging itsura ng ating S orbital. And ito yung ating P orbital kung titingnan natin yung kanilang angular dependence. So, for given values of theta and phi, the length of the line joining the origin to the surface of the solid figure is the relative probability that the electron is to be found in that direction. For this PZ orbital, the maximum probability is along the z-axis. The other diagrams are given in simpler form, but they are to be interpreted in the same way. So, bakit kaya wala yung... Wait, what happened? I-cut na lang natin para hindi ako babalik pa class ha. Nabura ko ba siya? Ayan, para lang mas kita natin. Okay. Yan. So, as you can see, class, all s orbital natin, L is equal to 0, have spherical symmetry. Though, alam natin, class, for a fact na when you know the R, kasi yun lang yung pinakita natin kanina, no? If you know the R, mapaplot mo na siya. But then again, class, it would just be the same kung alam mo yung R, yung ating radius, yung radius, and then, alam mo yung theta, and then alam mo yung phi value, you would still have your sphere. So makakalculate mo pa rin yung sphere since we know for a fact last na coordinates naman ng sphere yung tatlo, right? So same lang din, pwede mo siyang i-apply sa sphere. Yung diniscuss natin kanina, applicable lang yun sa mga spheres, right? Yung diniscuss natin sa principal quantum number. But for this one, this is a more general kind um, of way on how you would come up with the accurate representation in 3D space of these orbitals. Now, so when L is equal to 1, this is a p orbital, the quantum number m sub L can have the value negative 1, 0, or positive 1. And there are orbitals that have their maximum values along the x, y, and z axis. So for this one class, yung maximum niya is nasa z-axis. Kaya siya p sub z. And then this one class, ang maximum niya is nasa x-axis. For this one, ang maximum niya is nasa y-axis. So this is p sub y naman. So anyway, so this is just the same. In a sense, class na, um, kung energy yung ating titingnan, but they are oriented in 3D space differently from one another by checking yung ating angular dependency, yung ating L and M sub L. Okay? So for the d orbitals class, which is L is equal to 2, meron tayong 5 equivalent orbitals. So we have tayo M sub L is equal to -2, -1, 0, 1, and 2. Right? So ang M sub L natin is from -L plus 1 hanggang L plus 1. From, asan tayo? Yeah, we have from L, right? So L, then L plus L, L plus 1, and then 0, then L minus 1, and then L. Negative L yung umpisa. Yeah, I'm lost again. So yeah, for this one, kung L natin is equal to 2, 5 dapat yung makuha natin. So -2, -1, 0, 1, and 2. Okay, so for this one, 5 dapat yung madodraw natin. So we have the dz squared. So para siyang pz orbital, pero you would found out na meron siyang donut sa gitna. And then we have the dx x squared y squared. If I'm not mistaken, na-discuss na natin um, yung reason kung ba't x square, y square yung representation natin for this one, since we know na yung ating value for x, no, and for y, kapag kinonvert sila to uh, to the spherical coordinate, would give us this relation x squared y squared for this orbital. And then we have this orbital. So tatlo sila, pwedeng dxz, dyz, and dxz. Pero 4 lobes lang. Okay? So pwedeng z or y, pwedeng y or x itong axis natin. Okay? So para lang hindi madami siyang drawings. I got these images class from Lidler. So for example, with L is equal to 2 and ML is equal to -1, we obtain from tables 11.11.3 the product. So we have, of course, if you're going to, of course, i-check, kukunin lang naman natin yung kailangan natin, no, from table 11.11, and then multiply natin. So we got the phi y, okay, phi equation y, and then this phi y class is for m sub L is equal to -1, okay, and then we have the theta to positive -1. Okay, so we have sine phi over square root of pi multiplied to square root of 15 over 2 sine theta cosine theta, which is, this is, wait, yeah, tama. So, or equal to 1/2 ng square root of 15 over pi sine theta cosine theta sine phi. Yeah. So, ni-rearrange lang natin, sinimplify. Okay, so from the previous module, we see that y is equal to r sine theta sine phi, and that z is equal to r cosine theta. So the product yz therefore has the same angular dependence. Kung i-multiply lang natin sila class yung y and z natin, you would see na it is like you have an r square sine theta cosine theta sine phi, which is just the same as this one. So you got sine theta, cosine theta, and sine phi, right? So ibig sabihin, same siya ng angular dependence. Same ng angular dependence, itong nakuha natin for L is equal to 2m sub L is equal to -1 na wave function. Same siya sa angular dependence if we just multiply the y and the z axis. Yun yung reason kung bakit yung designation natin for this d orbital is dyz. Okay? dyz. And if you're going class to look at the wave function, kapag kinalculate ninyo, so kuhanin nyo na lang, for example, ang kinuha ninyo is phi x or phi z. Tapos multiply natin with this theta equation, we multiply, you would see class na yung ating angular dependence would be just the same as the product of yx and product of zx. Okay? So, yun yung reason kung bakit may designation tayo ng dyz, dxz, and then dyx. Okay, so just try to check and look for the other things para lang mapaikli natin, no? Para lang makat natin because we're running out of time. Okay, so yeah, I think this would be the last slide for this module. So we have the f orbitals, which is equal to 3, yung L natin, which are difficult to present, but they bear some resemblance to the d orbitals. There are 7 such orbitals, -3, -2, -1, 0, 1, 2, and 3, yung m sub L values. 3 of them, we have the fz cube, x cube, and y cube have 2 donut shape, rings perpendicular to the appropriate axis instead of the one found in the DZ squared orbital. So yung DZ squared orbital kasi natin class, meron siyang isang isang donut lang na nasa XY plane, right? For the Z cube, X cube, and FY cube na orbitals, meron silang donut shape na rings na perpendicular sa appropriate perpendicular dun sa kanilang axis. Dalawa. So for example, kung Z cube, so may dalawa kang donut sa ibaba na hindi nakalapat sa XY plane. Okay? So you get the point. And then for the X, of course, so ganun din. So perpendicular lang siya dun sa x-axis. So yung donut natin, ano? And then yeah, the other four resemble the dx squared y squared. So kung napansin niyo yung x squared y squared natin, para siyang for this one class, uh, paano ba natin sasabihin siya? Yung ating lobes kasi class, pwede siyang mag-fit in mismo sa xy plane or pwedeng in between those. Okay? So in between those siya. Kaya nga lang ang pinagkaiba niya dun sa dx squared y squared for the remaining 4 na f orbitals is 8 naman yung lobes niya. So 8 na yung lobes niya instead of just 4, and then ganun din yung kanyang orientation. Almost the same as dx squared y squared. Anyway, so hindi naman tayo abot up to the f orbital, and this would kumbaga this would just be more on like trying to um, visualize kung ano sila in 3D space. Ano? At dinamay na lang din natin si F orbital. But then again, hindi naman siya hindi it's not that hindi siya scope, it's just that these are way complicated for the trigonometry. So even class kami sa MS na or not kasi sa Diliman thermodynamics kasi ang focus. But for UPLB, if you would like to try to advance your quantum chem, especially regarding the F orbitals, pwede kayong pumunta sa UPLB. Yung kanilang physical chem dun is quantum. So for the masters, no? But anyway, so medyo mahirap kasi humanap ng books na detailed siyang dinidiscuss. And of course, since hindi nga siya for the elementary level lang. Anyways, for what has been said, it might be thought that the various orbitals corresponding to a given value of L would mean that a complete orbital diagram for an atom would look like a pin cushion. So para siyang, isipin ninyo, meron kang pin cushion, tapos nakatusok doon yung mga pins natin. So hindi siya like spherical lang, like yung shape, kundi marami siya iba't ibang mga protruding na orbitals. So ganun yung pwede nating maisip na itsura niya. However, a theorem, we call this the unsolved theorem, due to the German physicists Albrecht, Otto, Johannes, and Sold, states that for the orbitals corresponding to a particular value of L, the sum of the values for the angular dependency, phi, and multiplied to the theta equation square is a constant. So such a sum therefore corresponds to complete spherical symmetry for the atoms. So it follows from this that the atoms of the noble gases in which all the orbitals corresponding to a given L value or field have complete spherical symmetry. So ang gusto niya lang sabihin is sinasum up siya. So sinasum up siya just for us to be given a complete spherical na shape for an atom. No? So yun yung unsolved theorem. Anyways, hindi naman tayo magdidigin into that. Sinama lang natin since kasama din naman siya sa book ni Lider. So yun lang class. That's just it for module number